A very good day. Today we are going to learn the binomial distribution by using Casio FX570EX Classwiz calculator using Mono 7 distribution. Objective is to find probability of binomial distribution using Casio FX570EX Classwiz calculator. Binomial distribution is for the discrete random variable with the n number of tries, and that tries has two outcomes, either success or failure only. And P is a probability of success, Q is a probability of failure, N is the number of tries, X is the number of successes in n tries. X can be any number between 0 and n. Tips to use the calculator distribution. And then if you use binomials, okay, PD number 4, it has list and variable. It's used when you want to find probability of X equal to K. And then if list, it will list down. Okay. If variable, let you find the probability of X equal, okay, what's the K value, number of tries, probability of success. Okay, if you want to find probability of X less than or equal to K, then we use the binomial CD. Okay, again list will list down the cumulative, okay, distribution, okay, binomial cumulative distribution. If we use variable, then remember the area, okay, for calculator is left till area. That's why you can find the probability of X less than or equal to K directly. Key in the K value, number of tries, number of probability of success. If right till area, if you want to find probability of X greater than or equal to K, then K probability of X greater than or equal to K. Then you need to minus it. We'll look at the following example. For example, given that X satisfies binomial distribution, this is n equal to 5, probability equal to 0.5. This is a binomial distribution, and number of try is 5, probability of success P is 0.5, and then we want to find probability of X equal to 3. X equal to 3. Okay. So X equal to 3, then we use Mono 7 binomial PD number 4. Variable X is 3. Okay, then you equal N is 5, P is 0.5. Then you get the answer 0.3125. 0.3125. Again, you can also calculate it using binomial formula like this. Okay, you can calculate using 5C3, 0.5 power 3, and then 0.5 power 2. Then if you use normal calculation, 5, so you have 5 C, X is 3, 5C3 time probability of success is 0.5, X number of X is 3, so we power 3, and then time probability of failure was 0.5 because 1 minus P. Okay, and then the power add up will be 5, so this will be 2. So again, 0.3125. This is using binomial distribution formula. NCX times P to the power of X times Q to the power N minus X. or we can quickly using the menu 7 binomial PD variable, key in x is 3, n is 5, p will be point 0.5. Let me get the answer quickly. Okay, and then probability of x less than 4. Less than 4. So mean start from 0, 1, 2. Okay. Discrete, so mean not inclusive 4. So equal to probability of x less than or equal to 3. Okay, you may calculate manually using binomial distribution formula. Mean this is a probability of x equals 0, x equal 1, x equal 2, x equal 3. Or we can easily using binomial CD. Yeah. Binomial CD, number 1. Variable. Okay. Probability of x less than 4. So mean inclusive x equals 0, 1, 2, 3. So x will be 3. So this is a binomial CD. X is 3, n is 5, p 0.5. So you get the answer 0.8125 directly instead of you calculate manually like this. Okay. And then how about the probability of x less than or equal to 4? Mean inclusive 4. Hence, okay, if we quickly use binomial CD, x inclusive 4. So this is binomial CD, x up to 4. Less than 4, so x, we put it equal to 3. Now, x less than or equal to 4, x here, we put 4. So answer 0.9688. So the answer is 0.9688. Okay, the probability of x greater than 1. So mean greater than 1 mean will be 2, 3, 4, 5. Right. Okay. If you want to calculate manually, we will calculate probability of x equal greater than 1. So 2, 3, and then 4, 5. Or, okay, since the total probability will be equal to 1, you will take 1 minus probability of x less than or equal to 1. So mean minus. Okay, you got x equals 0, x equal 1. So minus these two. Or you want to 1 by 1, probability of x equal 2, equal 3, equal 4, equal 5. So I will use this because binomial CD, it will calculate the left tail area. Okay. Then I want this. So we calculate probability of x less than 1. Okay, it's actually if you have these two value. Okay. Then I will put up 1. So it's 0.1875. 0.1875. Then, and in the distribution menu, we cannot do others calculation. So I got to go back to menu 1. So 1 minus answer. I get here 0.8125. Here actually 0.1875 is equal to, it's a probability of x equals 0 plus x equal 1. We try to add up to see 0.0313 plus 0.1563. Right, this thing. In these two you add up. Let me see whether I can hide. I mean, these two you add up, which is this one. Alright. So mean probability of x greater 1, I will calculate as 1 minus probability of this thing, these two. 1 minus probability of x less than or equal to 1. And then, okay, probability of x less than or equal to 1, I use a binomial CD, input x is 1. I get this value directly. instead of you calculate manually one by one. Okay, if probability of x greater and equal to 1, so mean will be what you want is here onward. Okay, add up with the probability of or 3, 4, and then add up with probability of 5, right? If you want probability of x greater than equal to 1, so mean, and then using the calculator, we will take the probability of 1, total is 1 minus probability of x greater and equal to 1. Oh, sorry, greater than equal to 1, so inclusive this, inclusive this. Probability of x greater than equal to 1, so means start from x equal 1, 2, 3, 4, 5. So will be, you will calculate as a probability of 1 minus probability of x equal 0. Right? 1 minus probability of x less than equal to 0. 1 minus this value you get here. Right? And then probability of inclusive 2 and also inclusive 4. In between 2 to 4, inclusive both and point there. So we'll calculate mean is actually probability of 2, 3, 4. 2, 3, 4. So it's either you you calculate it one by one, or you want to use the binomial CD. I will calculate as mean 2, 3, 4. So I will take the probability of x less than equal to 4. X less than equal to 4 means start from x0, x1, x2, x3, x4. So you minus the probability of x less than equal to 1. Like this. So probability of inclusive 2 to 4, I take probability of x less than equal to 4 minus probability of x less than equal to 1. And then you use the scientific calculator, menu 7, binomial CD variable. You calculate probability of x less than equal to 4, means start from 0, 1, 2, 3, 4. So you put up x is 4, because inclusive 4, n is 5, p is 0.5, 0.5. So you get this value, 0.9688, 0.9688. Then from 0, 1, 2, 3, 4. The answer is 0.9688. So minus with probability of x less than or equal to 1. Mean these two, x less than or equal to 1. Just now we already calculate 0.1875. And then let's say if you do it in one time, let's say store this value to a. And then now minus with probability of x less than or equal to 1. You put up 1 here. So you get 0.1875. 1875 probability of x less than or equal to 1 means probability of x equals 0, probability of x equal to 1. This one is stored in the last value is stored in the answer. Now I go back to menu number 1. I will call back a, alpha a minus answer. So it's 0.7813. Or else, you do using binomial distribution formula, probability of x equal to this one, add up probability of x equal 3, add up probability of x equal 4, 2, 3, 4. If the number is small, then can do it that way. If a big, then will be easy. You use a cumulative distribution function. So I repeat one more times. One more time. Probability of x equal 3 using binomial PD, input x equal to 3. And then probability of x less than 4, you use binomial CD, x less than 4 mean not inclusive 4, then we use a probability of x less than or equal to 3. Can I have the eraser? Okay, so for probability x less than 4 is equal to the probability of x less than or equal to 3. Then in your binomial CD, okay, menu 7, go down, binomial number 3, binomial CD number 1, variable. Okay, I want to see, to list down for you to see here. This one you key in 3. X will be, N is 5, P is 0.5. So you get here. So if x less than or equal to 4, x will be 4. 0.9 x number 3. Okay. Okay. Let you see the. Okay. If you want one by one, then number 4. Binomial PD list down. Then x you have 0, 1, 2, 3, 4, 5. 5. P is 0.5. Then it lists down here. X equals 0. This is a probability. X equal 1. 1,563. X equal to 0.3125. X equal 4. 0.3125. X equal, okay, 4. Here 0, 1, 2, 3. 4 is here 0.1562. X equal 5. 0.0313. Okay, so you can list down. Then in this case, x less than or equal to 4, either you want to add up from x equals 0, x equal 1, x equal 2, x equal 3, up to x equal 4. Okay, or we can have another one, distribution. See binomial CD. We choose list. This is a binomial cumulative distribution function. Very keen until 5. P is 0.5. This one gives you the cumulative distribution function. So this is a cumulative, meaning you add up the first one, F, capital F1, 0.1875. So mean or add up x equals 0, x equal 1 here. Probability of x less than or equal to 1 here. Probability of x greater 1 means start from greater than 1. So mean is greater than 1. So will be x equal to 3, 4, 5. So in 1 minus probability of x less than or equal to 1 here. You read binomial CD 0.1875. X greater and equal to 1. So means okay 1, 2, 3, 4, 5. So will be equal to 1 minus probability of x less than or equal to 0. Here 0, this value 0.0313. Okay, 2 to 4. So this is F4, 0.9688 minus with probability of x less than or equal to 1 here, 0.1875. So with this, thank you for your attention.